This is a potential divider circuit, and in a potential divider circuit you need a source of electricity or EMF. You need two components with a resistance. This can either be resistors, light dependent resistors, thermistors, potentiometers, variable resistors, anything that can give out a resistance. For this example, let's say the power source was 12 volts and the resistance across this resistor is 4 ohms. The resistance across this resistor is 2 ohms. And I wanted to find the voltage across the 2 ohm resistor. So first I need to figure out the current in the circuit, and I'd do that using V equals IR. 12 volts equals I, which is what we're trying to find out, times R, and R is always in a series circuit, you add the resistances, so 4 plus 2 is 6. I equals 12 divided by 6, I equals 2 amps. So the circuit contains 2 amps of current. So next stage is for me to try and find the voltage across this 2 ohm resistor. Again, V equals IR. We need to find the voltage. We have the current of 2 amps times the resistance of 2 ohms. We have voltage equals 2 times 2, which is 4 volts. So we have the voltage is 4 volts across this 2 ohm resistor, and across this resistor you have V equals IR again, but voltage equals the current of 2 times the resistance of 4 ohms. Voltage equals 8 volts. And what's interesting is if you add the 8 volts and the 4 volts, you get 12 volts, which is the initial source voltage. So now we've got that covered. You can also think of it as ratios. So the resistance is in a ratio of 4 to 2, so 4 over 6, because 6 is the total amount, so 4/6 of the voltage is across this resistor, and 2/6 of the voltage is across this resistor. So 4/6 of 12 is 8, and 2/6 of 12 is 4. So you might be thinking, what's the point of a potential divider circuit? And the point is to invert resistance values. So say I had an LDR right here. That's an LDR. And you know, as light intensity increases, the resistance decreases. But what if I wanted as the light intensity increased, the resistance to increase as well? So as it got lighter, the LED got dimmer. That wouldn't work in this example, because as the light intensity increases, the LDR gets a lower resistance, so the LED will light up more. So to solve this problem, we use potential divider circuits. So in this circuit you have the power source and then the potential divider circuit, but instead of a fixed resistor here I have the light dependent resistor. And as the light intensity increases, the resistance decreases, so the voltage decreases, so it will be dim here instead of bright. That is the reason we use potential divider circuits.